So let's get started with the lecture part of today. We have a couple of topics left. We have lecture number 9, we have lecture number 10, which are kind of loaded with some stuff. So what I'm going to do is probably go through number 9 today. Number 9 is on networking. And number 10, just so you know, it's going to be probably on Monday after the final exam review. Or we probably will cover part of it along with the final exam and then finish it up on Wednesday. The last one is on garbage collection documentation and nested interfaces in classes. Probably won't talk about the nested interfaces in classes, but we'll definitely get into garbage collection as a topic. So today's lecture is going to be on network programming. And it's a fairly simple lecture. And let's see, so someone tell me when it is 6:30, because we have some people showing up to do that, to do a sales pitch, I guess, on the recruiting stuff. So I have to make sure I stop on time. So manipulating URLs. So in terms of networking, what are we talking about? We're talking about going to internet websites. We're talking about connecting TCP, UDP. We're talking about using URLs. And there's a package for that. So in terms of the Uniform Resource Locator, which is what URL stands for, there's a reference to an address, and there's an object that we can create that is a form URL. And so it's already pre-formatted with all of the information that we can use. So we can get different parts of the URL and we can manipulate it to a certain point. So URL is the acronym for Uniform Resource Locator. It's a reference to an address. So sample structure here of the URL, the source name part can contain the host name, port number, optional. Anyway, you've all seen them before because you just haven't crawled out from under a rock, I hope, and you've been on the internet. So we know this one probably for, well, not really Sun anymore, it's Oracle. So you can create a URL object in Java from an absolute URL or relative URL. So you can take part of it or you can take the full path and you can create an object out of it. So the class receives several different methods that are implemented on the URL object. So you can get the protocol, the host name, the port name. You can get all of the little pieces of the information that we all stick in there and take for granted. And here's an example of what it is I'm talking about. So we've got our imports now are java.net. You're going to use java.net for web, HTTP interface, for UDP, TCP, all of the different types of networking that you could possibly do. In fact, you can use it for practically everything. Java I/O is the one for, it's going to be for the input, the output. You know, it's just regular old file manipulation, you know, to open a file, to close a file. So here we have our class. It's going to be called parse URL. In the class, we've got a main. Main's going to throw an exception. Hopefully we know that. We don't have the exception handling in the slide, but we know what we're doing there, I hope, at this point. So here's our URL object that I was talking about. So URL space a URL equals new URL. And then we have HTTP : /, you know, anyway, it's a URL. The URL is kind of long, actually. And here's another example, or the first time I think I've actually shown you this. If you want to make it like, you know, word wrap without having it to word wrap, you just want to cut the line short so you can kind of, like, for example, in this slide, so you can sort of see it all in one shot. You can use the plus for concatenation on your source code. So here we have, you know, quotation mark ending the string plus this string here. You can actually do that with your strings as well in your source code. So a lot of people will take, you know, let's say a variable as an example and add it with another string. You know, my name is plus username. So you basically mix in the variable. But this is doing it for a slightly different purpose. It's doing it essentially in the source code, so it makes it look like you can put it all on one line. Why do you want that? Well, you know, in particular cases, as this one as an example, you can get the lines can get kind of lengthy. So it's easier sometimes to see it this way. So now we're going to do a system out, and actually all we're doing is creating the URL object in this example. And then we're doing a system out, and we're running all the methods on the URL. So what we're doing here is we're saying, you know, a URL, which is the URL we created right here, you know, .get protocol, get host, get file, get port, get reference, and then print it out. So actually it's the other way around. We're host is equal to plus get host. File name is equal to plus get file name. And now I can kind of see why, hopefully maybe, I don't know, why we use the pluses in here, because it looks easier to kind of conceptualize what it is you're printing out. You don't have to do it this way. You could put it all in one line if you wanted to and not use the pluses. The output of the code looks like this. So we have the protocol, which is equal to HTTP, which is really just the first part. So you basically created a string, and the methods that you're using on the URL object are just parsing the string for the different parts of the URL that's built in. So could you do this on your own without using the URL object? Yeah, but it's easier. So it's just a way of automating it. Instead of making a string and then having to find, oh, you know, HTTP is 1, 2, 3, 4, 5, 5, 6, 7. Okay, so the first 5 characters, or the first 4 characters, that's this. You know, instead of going through the manual kind of parsing, the URL object does it for you automatically. Some of the information also in here looks like, for example, the reference is, you know, downloading. The port, you know, 80 here references this document name downloading. So again, we're just parsing the information when we're running those methods, and it does it for us automatically. So connecting with a URL. So OpenStream returns an IO input stream object that you can use to read easily as reading from an input stream. So it might throw an IO exception, so we're going to throw exception on this. Let me zoom in a little bit so you can see. Same includes as before. This one in particular is going to be read URL, and so it's going to read what's at the URL and put it into an input stream object. So here's our public class main, throws IO except. Actually, this one here is just throwing an exception. It's going to catch an IO exception. The URL, this is actually Oregon State University, so I should change it to ISU. But it came out of a book that said that anyway. Long story short, equals new URL, and then the URL, I changed the URL here, it looks like, itu.edu. And then this is the same as we were reading and writing files, but we're reading from the URL. So it's the same process actually then. In fact, we're using, and this is coming from Java IO, which is the input stream from buffer reader. So buffer reader in is going to be equal to new buffer reader, new input stream reader, open stream. So the method open stream follows the URL out to itu.edu, takes the whatever's out there, which is the index.html page or index.something, takes that and reads it in line by line. So the string input line here is going to say input line is equal to new in.readLine. So while we still have lines, basically take all that information and read it in. If you remember what we did last time, I believe it was last time, when we went through all those notepad examples, was it last time or the time before? I took maybe it was the time before, I showed you one of the examples had a bar, text bar, where you put in a URL and you press go or something, and then it showed you the information on the screen, but it was just the text. It wasn't formatted in HTML. Well, if you look at the video or you run through that example that's in the zipped file, you'll see, in fact, it was the first, it may not have been last time, I think it was the time before. It was the first notepad example I showed you, did this. It took a text, it basically went out, it created a URL object, it ran in the OpenStream, which the OpenStream method is going to go essentially to that URL, open it up, read what's there, which is the index file. It does not read the entire website, just the index. So we'll get the index.html file. And then you could take that and you could put it into a web browser, or I don't know, you could take and put it into a notepad, which is what that notepad example is doing. So yeah, I believe it's 2 lectures ago. If you run through some of the old videos, you'll see it. But essentially, you can redo it yourself if you wanted to with this code right here. So this prints out the source code of the web page that's at itu.edu. In fact, this will do the same thing. So if you compile and run this and make sure that you put on a valid URL, it goes out to the URL, takes the whatever it finds, the main page, it would actually show up in your web browser, and basically print it to the screen here because we have a system.out print line. It's going to print the output to the screen. So it's actually kind of nifty. You think about it, all this code does what your web browser does, essentially. But web browser, let me talk about web browsers for a second. This is text. This is input stream. In order to create a web, and you can actually create a pretty decent web browser in Java. In order to do that, you got to build functionality. What's the functionality? Formatting an HTML, parsing HTML, lining up it, reading the HTML, and then you got the plugins. Today's web browsers are fairly rich in terms of features. So, you know, reading the Adobe file format, video file, audio file, it's a real challenge, actually. In fact, I give a lot of credit to those who write web browsers because they're not easy. And if you haven't noticed it, probably web development is probably not as easy as it used to be either, because every web browser supports everything a little bit differently. So Firefox will have different interpretation of the data than IE will, Internet Explorer, versus Chrome, versus all the other web browsers. So it really does make a challenge, actually, to web developers, because it doesn't all look the same in every one of these browsers. That's because someone wrote the program to go out there, pull the data, and the data coming back in a text format, and then format it. Well, who's in charge of the formatting? The web browser. So the web browser is parsing it, web browser is displaying it. So, in fact, you can create your own web browser out of this sample code if you wanted to. So here's an open connection. So the previous slide we looked at the open stream, which opened up the stream, read it in. The open connection returns in a URL connection object that represents a connection to the remote object referred to by the URL. So it throws an IO exception. The first one is actually going to throw a regular generic. I believe it, you know what though, I believe that it would also throw an IO exception because it wouldn't be able to read the IO stream. But long story short, this one specifically does throw an IO exception. And here's the example here where we have the URL. This is the OSU is the name of the object, is equal to new URL. Here's the URL. URL connection. So it's a new connection object called a URL connection. So the connection itself, OSU connection, is going to be equal to, well, here's the connection, open the connection. Now we've actually established a connection. So this is like a point-to-point connection where we're looking at, and what would be equivalent to what would be considered a TCP transport protocol. So we have a constant connection versus a data packet where we would create some information, send it, you know, receive it, send it, you know, kind of open and close connection. This opens a connection for consecutive reads, consecutive writes, or whatever it is that you want it to do, versus just opening the stream. Opening the stream just goes to the URL just like a web browser. This is, now we're getting into networking. We start looking at connections. So the URL connection class provides many methods to communicate with the URL, such as reading and writing. Now the concept of sockets come into play, and I know you guys are just dying to hear about this stuff. Usually when I mention networking, every one of the students go, what? This is not a networking class, it's a Java class. The thing is, if you're in a networking class, this is the fun stuff, because this in Java is easier, much easier than C++, much easier than other languages. And half of you who are in the Android class are going, well, what do you mean? You know, why do we need to learn this stuff anyway? And you can do this on the Android too. You can actually use the URL object. In fact, some of my examples already have been using the URL object on the Android platform. Also the open connection. Also TCP, UDP, and I have a lecture on that today as well. So both of these classes are going to sort of tie in together today. But this concept of the socket is rudimentary to networking. So people from a networking background go, oh yeah, socket, same socket you're familiar with already. Sometimes you need a low-level network communication, such as a client-server application. So it's nice to go through a web browser, but web browsers don't do everything. Sockets create one-to-one connections between this computer and that computer, generally referred to as client-server, could be distributed as well. You can have a host connect to another host, a peer connect to another peer. It doesn't necessarily have to be a client-server type of environment. Then we have TCP and UDP. TCP is the constant connection. So and you don't really have to know anything. I'm not going to go through the OSI model. Don't worry about it. So that's where people start going, oh no, she's mentioning networking. TCP protocol provides the reliable point-to-point communication channel between sockets. What's a socket? A socket's bound to a port. The port in this particular example, if we're using HTTP, it's 80 port 80 or 88, sometimes it's 81, 82. Depends on what you've got open. So the way you create a website is you open up a port on your router and you basically allow outside traffic to come into it. Open up a door, and then you stick stuff on that port, and you bind the port to something like a web server. Stuff in the web server. They go through the port, they connect to your web server, and voila, you have a website. So take a Unix course, though. That's not everything. There's more details to that that you'll need. So a socket is an end-to-end point, reliable communication. Usually when we talk about TCP, we talk about sockets because we want a connection-oriented situation. So we have two machines that are connected. They connect to each other. Each of the clients and the server binds to a socket, and it's basically binding for reading and writing. So we usually have a socket created to send and one created to receive. So we might have multiple sockets running simultaneously. So the Java.NET package provides two classes, sockets and server socket. So to implement the client and the server respectively, let's take a look at this. You're wondering, why in the world do we ever have to do this? What if you want to create an instant messaging or a chat program? You don't want to use a service and you want to create your own. Or what if you want to create a client-server application? Or what if you want to put data out there on a server and you want to go get it? You have to basically do this. It comes in handy for a lot of stuff communication-wise. If your app is not communicating with the outside world, you'll never run into sockets or networking. But whose app runs on an island of their own? Everybody's app. It has some network component to this. So there's 5 steps in establishing a simple server. So what I'm going to talk about is just establishing a simple server, a simple client. We're not going to, don't worry about it. I'm not going to, actually don't even have the source code with me today. So I'm not going to bore you with the implementation. And you don't have to program. I showed you the last assignment for this class. So you don't have to program in this. I used to have an assignment though that was on this in the past. And then too many students struggled with it, and it doesn't really teach you very much about Java. It's like, networking. So, all right, so 5 steps. Create a server socket object. And this is why people love Java. Look at that. Server socket. Server is equal to, oh my god, that's how easy that is. Find a port. Get the queue length. How big do you want to make the queue? Wow, that's pretty easy. And then the server listener, listens indefinitely or blocks for an attempt by the client to connect. So we got the socket communication equals server.accept. Right there, we sort of created the server interface already in 2 lines of code. If you're a C++ or C programmer, you're like, whoa. Because it's a lot more complicated. There's a few more lines of code, but this is object-oriented. We're using built-in I/O classes, such as the server socket, rather than doing it manually. You can do this from a lower level, and then if that were the case, you could make the server listen in a non-blocked fashion. You could make, all sorts of different customized behavior out of this. But get the output stream and the input stream from the objects, because the server is going to need to communicate. It has to send and receive. So it enables the server to communicate with the client by sending and receiving messages or bytes. The bytes are going to be the streamed information. So input stream, input, output stream, output, connection.get input stream, connection.get output stream. And believe it or not, all this stuff can be done on an Android phone as well. Actually can be done on an iPhone as well, but slightly different syntax because you're using Objective-C instead of Java. Actually, as a side comment, this is much easier on the Android. It's kind of a nightmare on an iPhone. This is actually pretty easy on the Android because it's done in Java. So you can get a stream on the other end, other data type from the input stream or the output stream. Basically you're using one for input, one for output, and then you have the processing phase. So the server and the client communicate via the input stream and the output stream objects to go back and forth. Send me something. Okay, here it is. I received it. Here, I'm going to send you something. Okay. And basically the communication goes back and forth. After the communication completes, then the server closes the connection, invokes a close on the socket and corresponding streams. So that seems pretty easy. That's the server. So to create a simple client is actually even easier. So you're pretty much doing the same thing actually, but you're creating, instead of a server socket, you're just creating a regular old socket. The difference between the server socket and the socket is the server socket has accept, which basically puts it into a wait mode. So it listens and it just sits there. And it's not a loop that you have to create. You just basically run the method and it puts that object in sort of a standby mode, waiting for somebody to connect to it for indefinitely until you break it, or until you Control-C or get rid of it somehow. so there's 4 steps to establish a simple client. So you create a socket object. So we have socket connection is going to be equal to socket server address, because the client is attaching to the server. You give it the server address and then the port, the open port that it's sitting on. So we always have a network address and we always have a port. So unless you've done this before, you're probably familiar with network addresses, because that's the www.yahoo.com. That's the network. That's the domain name attached to the network address. You can actually use domain names here, like localhost or I don't know, itu.edu or whatever. Whatever domain is registered, it's findable. And then the port. The port's the important part, and the port is the same port that the server's sitting on, hopefully. So you have the server running first, and then you attempt to connect to it by multiple clients. So you get the output stream and the input stream of the socket, same as the server. The server and the client must send in and receive the data in the same format, obviously. That speaks the same language, otherwise it can't be interpreted. In terms of the processing phase, the server and the client communicate via the input and the output stream objects the same. So it's the same stage. After it's completed, the client closes its connection. So it's so you put a server out there, it sits there, and then you have multiple clients that go and connect to it. Isn't it kind of like the way a website works, actually? You stick it out there. Actually, it's run through HTTP. It's not through client server, not through sockets. But essentially, it's the same concept. You have one server location with a URL and a port, believe it or not, but you're not mentioning the port because it's automatically. It's the only open port on that server. So you're always going through the same port. Well, or series of ports. You go www.itu.edu. There's one itu.edu sitting out there, and there's hundreds of clients that all connect to it. That's client server. And if itu are connecting to something, something else, another server, a database server or something, which it does, actually, EMS, actually, then you've got distributed. That breaks out of client server and puts you into distributed computing, because you have multiple applications running on different computers, and it's all networked together. So that's where that word's coming from. So here's the pair example of a simple server and client put together. Here's the server side. This is the source code, actually, because what we did is we went through the steps. If we were going to write the source code for this, it's actually not too bad. All the same stuff up here. A Java lang, well, that one you can probably leave out, but IO.NET. If you're using, in fact, you can write this in Eclipse as well. In fact, you can cut and paste this code, put it into a project, compile it, run it. My thing is you'd have to open up 2 DOS windows. Open up the first window, run the server, let that sit, open up a client, and then figure out what port that server's sitting on. Get the local host address, whatever that might be, probably localhost, and then connect to that server from multiple different windows, if you were to test this. So here we have the class server, and these would be basically Java classes that would be put together. So you have one class for the server, one class for the client. Here's our class server, and in here we have our main, and our main's going to, and now we're seeing more of the try and the catch because we're doing networking. So anytime we're doing I/O, networking, we're going to always see this exception handling being performed. String data, let's test if we can connect, just a piece of information that's going to be sent. So here on the try, we're going to put everything that's going to cause an exception in the try, if you remember that. Server socket is equal to new server sockets. 1, 2, 3, 4. That's the port. So it's just the port. So system out, I've started. Dear clients. It's just going to sit there and probably announce its port, actually. Then we have the socket is going to be equal to the server socket.accept. It says put me in the mode to wait, block this port, and accept incoming clients. This is creating that kind of endless loop state machine where the server just sits there and waits. And then print out server has connected and sit there. And then we have a print writer, output to client, which is going to be an object that's going to send output to a client. So when a client connects to the server, it's going to say, hey, I found you. I connected with you. Some feedback to the client. So this is going to be a new print writer, socket.getOutputStream, true. So it's opening up an output stream. So we have an input stream, we have an output stream. So in comes from the client, out goes to the client. And the message that was going to be printed out would be sending a string. In fact, in the code here, it looks sequential, and it sort of is, because accept is going to wait until it accepts. After it accepts, it's going to go to the next line of code. Next kind of line of code. This is when this is going to say, oh, well, okay, we're connected. So we're connected to the client, because this isn't going to happen until this is allowed to continue running. So this pauses the entire execution of the program momentarily while it sits there and waits. Then it's going to go, oh, okay, I connected. Okay, get this, get that. Do all this busy work essentially and print out to the screen, sending a string, and here's the data from the string, let's get connected or something. And then output to client.print the data from the output stream, because the client would have sent information in that's going to be outputted. And then we're going to close the socket, so socket.close, and then perform some exception handling essentially. Oops, it didn't work. It's our message that's going to be printed out on the exception. So that is a server application. Here is the client version of the same application if we write it in source code. And notice it's just one page of code. One page of code. It's very simple. It's not a bad test, actually. In fact, if you ever continue and you take a networking course, you have a client-server program here you can borrow. So, not that you're going to need it, but on the client side, it looks very similar, actually. We've got a socket. Socket is equal to new socket. Localhost 1234. Because the server loaded up and said, bind the socket to this port, and the port that we assigned it to is 1234. And usually I have a student or two that asks, how do you know which ports are available? Anyone. You've got like thousands of them. So just pick one. 777 if you want. Just any port number is generally open. Your odds of it not being open, especially if you're behind a firewall, they're all open because none of them are being used because they're all closed to the outside world. If you do have a busy port, I'd check to see what's on it because you have something running on your computer that you don't know about that's opening up and using one of your ports, which is not a good idea. So the way hackers get into computer systems is they go through routers with open ports. So usually you only open up the port that's going to the public HTTP interface, which is, your 8080 kind of, your de facto standard port that's going to that website location. So if you tell your router, open up all ports, anyone who wants to can actually just connect to your network anywhere. Just like this, actually. In this particular source code here, just we're connecting to a port. But we're doing it from behind the firewall or behind the router, which is internal to your computer. In fact, both of these two programs can be run on the same computer, or you can run them on separate computers if the computers are on the same network. They'll find each other through the local host, which is the local network. So if they're not on the same network, you can put in a URL address here and make sure that that port is open in the router. Not such a good idea. Because if it is open in the router, you're letting anyone come through that port. There's no protection, long story short. Okay, so create the socket. And then we have the buffer reader. In from the server is equal to new buffer reader. This is going to be a new input stream reader, the socket.getInputStream. No brainer there. Just get the input stream. And then print a message out to the screen that says receiving a string. And then while in from the server is ready, while we're receiving from the server, print that out in .read line. So read one line and output it. Read one line and output it. And we're in a while loop when we're doing that, actually, until this is false. So when the server's done, it's not ready to deliver anything more. It's already given you everything. And then take the in from the server. Take this stream and close it. So you basically, when you close it, the server knows, oh, they closed it. The input stream, the output stream, so they can basically see that you've received it. And then here's some exception handling. Oops, it didn't work. So that's a simple client that goes along with the simple server. If you run it, it sort of looks like this. As I mentioned before, you're going to open up multiple DOS windows. So what happens? on the screen if you run the code. First you run server.java, and you can cut and paste. Actually, I did this the other day, and it worked just fine. Still, even with the current version of Java, I know this lecture set's kind of old, but still works. So this is the output here. This is the Java test programs. If you're running here, run the server first, run the client second. Here's two clients running actually, and they're connecting to the server. So you kind of have to, in this particular case, we sort of fixed the port. What normally happens when you write this is you have the server print the port out. Hey, I'm waiting on port number 1234. So you can easily see on the screen, oh, this is 1, 2. Okay, so the clients connect to 1, 2, 3, 4. They will all connect to the same port. So there's no mystery. It's not hard-coded like that. If you hard-code it like that, also another bad design, because what if you run it again and again and again? Well, port's going to be used. So then you have to keep switching the ports to get a fresh connection kind of thing. Otherwise, it's waiting on this port and then closes the ports. So the port might be busy, or it might have some interesting error messages that might come out of that. So here's the simple, if you run the client.java without running the server, here's where you get the oops, it didn't work. So if you want to see how the error messaging works, the try and the catches, all you have to do is run the server, run the client code, don't run the server. It's not going to connect. The server is probably going to connect just fine, unless the port's busy for some reason. So put in a bogus port or something, or leave the port information out. And it can't bind, the socket's not going to bind to a port that doesn't exist, or that's being used by something else. So it'll print out, oops, didn't work. So. Datagrams, oh, that is TCP, by the way. So you can write your own TCP applications. And believe it or not, primitive programs out there that do updates and stuff to the internet are using this kind of technique. What do we have? We have an update server out there. And you press, oh, check for updates. It's essentially doing the same thing. It's going out through a port, that's open port, through your web, your HTTP interface actually, to a server, opening up a stream, downloading the information from the stream, using it, running a program, doing something to update the software, whatever that might be. So update programs work like that. Downloading, actually BitTorrents sort of worked like that too, which is kind of scary, because the thing with torrents is you're opening up ports and then you're letting it sit there so that other people, while you're downloading, other people can come in and go, oh, what's going on over there? And see what's going on, and they can, that's kind of dangerous only because you're exposing your computer. If you ever use those torrent software programs, remove the torrent, basically, and make sure you have a firewall up as well. But you're going to get a bunch of garbage coming through while you have the port open. Because you basically just kind of like left your house to go to the movies with the door unlocked and wide open. You opened up your computer and you're basically, outside of putting a neon sign up there, says, hey, house is completely unlocked and there's nobody home right now for at least 2 hours. Outside of doing that, you're pretty much doing the same thing. Because they know, the torrents know how long you're waiting for that download. Most people will turn it on overnight because, depending upon the download speed. And you're also going computer-computer, usually, peer-to-peer. So you're pulling it off of somebody else's computer that's turned on, and they might actually decide, oh, you know what, I'm going to the movies, I'm going to shut everything down. So they might actually close all their programs down and shut the computer off. If that happens, you're going to lose your download, essentially. And then it just sits there and waits until the computer turns back on again. And meanwhile, anyone who wants to can go through those open ports. So, long story short, don't use BitTorrents. Unless you feel like putting a big old sign on your computer that says, hey, out to lunch, left everything open for you. So, datagram. So if you're going to use UDP, which is the opposite of TCP, TCP is constant connection, that is managed, where we have information that we can check on the socket to see if there's activity. We can run utilities and stuff like that. There's a lot more to it than I showed you. I just showed you the basic stuff. UDP protocol provides a mode of connection less. So whereby datagrams are sent back and forth over the network and the datagram packets are used for the connection. So you're still using sockets, but instead of establishing a connection with a stream, you're packaging up a little piece of information and you're setting it off. And the way I describe this is sort of like datagrams are sort of like when you throw a ball across the street. If you're TCP, you're going with the ball. Like a basketball player, you know, that dribbles the ball, you're managing the ball. So you know that the ball is going to make it from one end of the street to the other end of the street. With UDP, the basketball player stays on one side of the street and just throws the ball blindly out into the middle of the street, hoping it's going to land on the other side of the street. That's UDP, when you just throw it out there. Because you don't know if it's going to make it or not. There's no feedback that comes back that says, hey, the ball made it. And the ball's the packet, by the way. So the datagram arrivals to the arrival time, the order of the datagram is not guaranteed. So it's used whenever information needs to be broadcast periodically. Actually, think of this different protocol, different format, but email works in the form of similar to UDP. Your ISP connection is TCP. In fact, if you remember the old days of Windows, you had to load on TCP, you had to load on IP, and networking, my networking stuff that you had to put on Microsoft XP. Actually, it was like ME, I bet they were 98. Does anyone remember any of that stuff? You guys all had computers when you had DSL. No dial-up connections, no manual configurations. Now you just buy the computer, you take it home out of the box, you plug the Ethernet cord into it, and it works. Yeah, it's pretty much the same. Well, in the old days, you actually had to load on the protocols, and you had to configure the whole thing yourself. So yeah, no, not anymore. I sound like that Uverse commercial. You guys don't understand how easy you have it now. Just need to start blowing up an inch or two or something. Okay, I watch too much TV. UDP example. This one's going to be get date. So we have java.net. Same as before, actually, it's the same networking packages. Nothing has changed. And here we have a port, a date, time, which is going to be equal to 13. It's just going to be an integer value. It's going to be final. And this is going to be just essentially actually it's static, so it's a class level. So all instances would share this. Here's our main program. Here it's going to throw exception. And what's it going to throw? Well, down here on the bottom. Well, actually, it's not even on this slide. So we have datagram socket. So instead of having a socket, we have datagram socket. So we have a little more sophisticated socket. Well, different type of socket. So it's going to be equal to a new datagram socket. And then we have the init address, which is going to be the destination, because we need to connect. We're a client, and we're going to need to connect to something. Or actually, because there's no constant connection, there really is no client server. It's an abstraction, actually. In the TCP example, we had a dedicated server that sat there and waited for connections. We had clients that connected to the server. UDP, it's like, you send me something, I send you something. We're both clients, we're both servers, we're just peer-to-peer almost, which is kind of like how email works. Alright, so we have the init address here, get by name, and put in a URL here that's valid, hopefully. And then we have the datagram packet datagram, which is essentially going to be having a message inside of it. And the message here is going to be a new message of, it holds bytes actually as a data type. So TCP holds streams, which are actually equivalent to strings, because we created a string data that had a little string that we sent to it. The UDP equivalent to that is the byte, actually, because it's a datagram that's holding data, not a stream. So it's not equivalent to the string, which is kind of interesting. But it can be bytes of anything, numbers, characters, data. It can be interpreted any way you wanted it to. So there's a little bit more flexibility. It's more raw in form. So datagram, new datagram packet. So we have the message, the length of the message, and the destination. So here's another interesting point to kind of consider. In the stream, we just send it. We send one sentence, or we send 50 sentences. Doesn't really matter. In the datagram, we only have a certain amount that will fit in each packet, and we want to know, what did we send, what was the length of it, so when we receive it, we know whether or not we received the whole thing. And then, what are we bundling here? How many bytes? So there's a little bit more managing of the data itself on a UDP connection. So the socket itself, .send datagram. Well, that's easy. We'll send it out. So once we pack it up, the datagram, and the datagram itself has the message is the byte array, and it has the message length and the destination, which is going to be 13, which is the port that we're going to connect to send it on. And it was just designated that port. Hopefully we have something on there to receive it. And so we send it, and then we send a string. This is we create a string received, which is going to be a new string, datagram.getData. Receive something back maybe. So, and then what are we going to receive? We're going to print out the time of the machine that at this particular time we received this particular data. So essentially, if we received it coming back, it would print that out. So here we go. We have Java get data. If we run it, we have time machine, and then it's going to basically print out the time. 2005. Print out the time that we received the response back. So it's kind of primitive. It's just kind of a send data, print out the time that you received the data sort of thing. Questions on UDP or TCP? And no, you don't have to use you don't have to program in UDP or TCP for this course. If you go on to take the EE course in Java, it starts right after this stuff, and it gets into higher level APIs that have incorporated all this stuff, like RMI as an example. That basically is another layer on top of TCP, and servers and server sockets for JSP and all of the other Java add-on products. So when you start studying Java, you pretty much stop at UDP and TCP. Everything past that is Enterprise Edition. So it goes past the JDK, and now you're into EE, essentially. If you are interested, there is some additional information on these supplemental readings, if you have an interest in that. What are you going to get on the final? Well, I haven't written it yet, but you're going to get some questions about UDP, TCP, and maybe one question, but I'll let you know on Monday. So it's not a heavy part of the course. So we still got some time before the... So I'm going to start this lecture, actually. We have a speaker who's coming in at 6:30 to give us a spill on job recruiting. Stick around, don't leave. Especially if you're not in the Android class, stick around because you might find it interesting. Job services, so don't quote me on that, but they have handouts and information on finding jobs for international students. Primarily focused on international students, I believe, but we'll see. I have no idea, really, seriously. I'm waiting to find out. We had one of these on Monday, and they didn't show up, so... But we're going to break at 6:30 regular, so someone tell me when it's 6:30. So. Garbage collection, documentation, and nested classes and interfaces. So believe it or not, we have Java docs that are created for us automatically, and we can write these. In fact, in Eclipse, there's an option to actually look at them and view them. Same way as we have an option for JUnit. We can actually create the documentation automatically using the GUI. And again, just like UDP and TCP and networking, don't have to do this for any of your assignments. However, in the real world, if you don't document your code, you're going to have some issues, essentially, further down the road with your boss. So you're probably going to want to look into this. I don't know if it's really... I don't like Java docs, personally, because... okay, first of all, I've never really spent as much time doing it in practice. But you actually have to pay attention to what you're documenting in terms of your internal comments. And there's a certain format to your comments. If you don't put them in the right formats, they don't show up in the right section of the Java docs. I prefer just to pull out a notepad or pull out a Word file because I'm very old school and just write my own documentation or just put comments in the code. This is not putting just comments in the code. This is putting stuff in the code so that you can press a button in Eclipse and automatically create Java docs. And Java docs are essentially going to be your documentation. If you've ever seen any of these Java docs, you'll go, well, that doesn't really say very much. Not very informative because it's kind of like garbage in, garbage out. If you don't write it, you don't get it. So you go, there's a method, it's called this. Okay. There's a class, it's called that. Okay. It's unless you actually sit there and put it all in, you're still right. It's not the auto part of it is auto in that it generates it for you, so if something changes and you regenerate it, automatically updates for you and everything. And it kind of keeps it organized, and it forces you to kind of follow a particular pattern. It doesn't write the documentation for you, and neither does the JUnit. JUnit doesn't actually write the test cases for you either. So, if you're not familiar, we probably will have enough time to actually cover JUnit, perhaps, but I'm not sure. I'm going to have a little bit of time on next Wednesday, a week from today, depending upon how far I get through today, to cover some additional topics, but we'll see. All right, so let me talk a little bit about documentation. So documentation comments. In the standard APIs, they are shown in HTML output. And what we see in the standard, in fact, let me see if I can, let me take this out for a second and go to this, and you'll see an example of these Java docs, because it's helpful to actually sort of see it. I guess I could have just pressed on that link, but I'm not quite sure if it would have worked. So, what am I talking about? Java docs. Here they are. This is for the standard APIs, and this is actually kind of old. And it opens. How many of you guys have ever seen this stuff out there? Isn't it lovely? I can't get anything out of this. I find this, okay, so don't quote me on this in any future, and I'm not mocking this at all, but I don't personally find this very useful. However, I'm impatient, and I haven't spent enough time to go click through. Let me just zoom out so you can kind of see what I'm talking about.
I think in the fourth assignment for the option, we need to find the colors and its font, all those.
If you go to the Java docs, that's okay. So she just came up. I'll repeat what you just said, so I'll reword it. But in one of the assignments, you actually have to go through to find the options for all of the different colors. I think it's the fourth one. That's what this is good for. Yes, because you can go to this. Okay, so this is the Java doc that is created for the API, and this is actually kind of probably an older API version. Find the one for the current one, and in here you can find all of the different color options. This is an encyclopedia of all of the different methods, classes, packages, options, everything you could possibly imagine that's documented out of the API. You can write one of these for your program that will look just like this. My complaint with the whole thing is that I look at this and it's just overwhelming.
Yes.
I get tired of just, what am I looking for? Oh my God, and it just never ends. And then you come over here and you go, AWT font provides classes and interfaces related to fonts. Hello? Isn't that self-explanatory? You know, it's not, this level is what I'm talking about when I say garbage in, garbage out. You have to write this line of code. You have to write this document yourself, and you're writing this in your source code, so that when you're all done, you press a button, and it says, you know, whatever it is that you actually coded in the code is actually going to show up. Which means you still have to document it. You still have to put the code in there. But, you know, anyway, you probably get my point at this point. I just don't, you know, if I'm going to do this, it provides RMI package, you know. Yeah. Perhaps if I was brand new, I would go, Java, what does that do? And if you click on it, here's the other thing too, though. If you click on it and you're in the Java docs for the package itself, if you click on it, you can go, okay, this is the interface, this is the class summary, this is the exception summary. It's just too much. I'm sorry. But I'm not a fan. There's other people that live on this, that if they ever want to find something, and then if you're looking for the colors and the fonts of everything you could possibly imagine, it's in this encyclopedia. So in the lecture is about creating one of these for your program. So now that you've seen the finished product, and believe it or not, that's an old one. The finished product today looks the same. It's the same white coloring with the same type of frames or whatever that is, the scrollable frames with the same click. And there's a reason actually why it's sort of consistent, but I really don't know what that might be. But there must be some reason why it's created that way. Okay, so the documentation comments. It's generated from the documentation comments. So we actually have to put doc comments in the code. The documentation comments are special comments in the source code that are delimited by these particular types of delimiter. So if you use the regular 2 slashes, you're not going to get this. So you have to follow a particular commenting format. You have to put the doc tags in the code to generate the tags. It's kind of like, if you remember, if anyone's ever used Microsoft Word, and you put the header, header 1, header 2, there's an option there that says, create an outline. Ooh, which is really nice, because it picks up the tags of all of the coding that you put in there that you used automatically for header 1, header 2, body text, all the formatting tags, and it automatically takes the page number and creates and formats an outline. Table of contents is what I meant to say, or an outline for your. And then actually you can get a reference list too, and you can, by going through, and you can automate the equivalent. This is what you're doing. All right, so the JDK tool contains a tool named Java Doc. You actually type in Java Doc. You don't have to do that if you're running with Eclipse. There's an option for it to create the Java Docs, and you'll see it on the bottom of the screen. Creates HTML documentation from documentation comments in the source code. So Java Doc utility extracts information from the following terms, and here's the items here. This is what you can get documentation for. Public classes and interfaces, public and protected methods, public and protected fields, so those are the data members, and packages. So it extracts the information from these particular items. Here's an example of what it is I'm talking about. So details on the doc comments. So the doc comment doc comment star with the 3 characters. So we have, we have to start with this particular 3 characters. 1, 2, 3. First, if we don't put the second dot in there, it's just regular comment. It's not a Java doc comment. Continues until the next one down here where we have this single. This is what I mean. You actually have to kind of get used to and use the commenting format. If you use the double lines, it doesn't work. If you use the single star, it doesn't work. So here's an example. Do what the invoker intends. And intention is defined by blah blah blah. And this is for that's preceding this particular method here. And public void dwim that throws an intent unknown exception. So the leading asterisk character and the preceding white spaces are ignored. And then the first sentence of the comment is the summary of the identifier. So long story short, as you're typing these comments in, pieces of what you're typing in are used for the title of the comment, the description of the comment, all of the different subparts of the pieces that are going to be put into this documentation. And it's parsed according to the order that you put the comments in. So the first sentence of the comment is the summary of the identifier. So this is just going to be a summary, essentially. It's going to show up here. So you can use the most of the HTML tags. So it's written in HTML, actually. So you can use most, but not all of the HTML tags in the text formatting. Or provide cross-reference links to other documentation. So you can put links in here. It says, see, somebody's document out here. And put a link in there so when the user clicks in the Java docs in the description area, they can click on the link. Because this whole thing is generated into an HTML format, just like what we saw a few minutes ago, actually. Only doc comments that immediately precede a class, so right before a class, an interface method, or a field, only those are processed. Everything else you stick in there are ignored. So it has to precede one of these guys right here. So knowing what this is what I mean. You actually have to learn how to document if you're going to document. But most companies that do this, either everyone does it or nobody does it, because it doesn't make sense if not everybody is doing this. Okay, so immediately precedes it. So this is immediately preceding this method call here, so it's going to essentially be accepted. If no doc comment is given for an inherited method, the method inherits the doc comment of its super type. So it'll take from something from its super. If a method inherits a doc comment from both a superclass and an interface, the interface comments are used instead of the superclass. Whatever is closest to the source is used first. If it can't find, it's kind of like constructors. Well, no, it's kind of like destructors in C++. It's not like constructors because they work bottom up. Whatever's closest to the source of where the comment is supposed to be, it will find and use that comment. If that comment's not there, it goes back to the super. And goes back and goes back until it can find something to document with. So the comment itself may not necessarily be relevant, or it might not necessarily be informative. So we have tags that we're using, and this is where I said you're learning another language when you're doing this. Tags in the doc comments. So we @C creates a cross-reference list to the other Java doc documentation. So it's used in a see also section at the end of the documentation. So @C this book, or see this website, or see this information. Qualify the identifier sufficiently. So you have to specify the class interface members by using the hash symbol here, or number sign, I should say, before the member name. If a method is overloaded, list its parameters. This is an example down here, actually. Specify class interfaces with their simple names. If the class interface is from another package, specify that package name as well. And then here we have so we have C, and this is going to say get name, which is going to be a reference to get name. C attribute in terms of the specifying the class or the interface. So see this one. C, here we have the attribute from host name, wherever that happens to be. So you can also label after an entity reference. So the label will be the actual text that's displayed instead of the reference. So if you want to, it's actually kind of like HTML when you're creating an anchor and you have a URL and you want to say, click here for this, or something, you can actually put reference a name that's in English or something, something that makes a little bit more sense. So you can put the attribute names over here next to a get name. Are we ready? Okay, I'm ready, actually. Let me just, oh, it's 6:23. So, actually, let me say this because what I'll do next time is I'll bring up Eclipse with some Java docs in it, and I'll show you that's a little bit less boring than looking at the PowerPoints for this. So, don't go anywhere. Don't go anywhere. Let me stop this video.